A few months ago, TikTok was banned in the US. And then it immediately came back online. But anyway, for that 12-hour stretch of time, the big question was, where will all the TikTok refugees go? That's when I had an epiphany. All TikTok is an infinite scrolling feed of videos. I could probably make that in one day. In this video, I'm going to take you step by step as I build out the front end and back end for a fully functional TikTok clone, complete with an intelligent recommendation algorithm that learns each user's interests based on their interactions with similar posts. I'm actually going to release it on the App Store, and if that wasn't enough, I'm challenging myself to do it all within 24 hours. What if TikTok gets banned again? America needs me! Since my last video took me 2 years, I'm imposing a consequence if I don't meet this deadline. Should I fail, I'm going to have to post an embarrassing TikTok. It is a little bit after 9 a.m., January 20th, so that's going to be our start time. Let's get started. Alright, so this is basically what we're starting with here. I've got a little menu bar with 3 separate tabs at the bottom and obviously nothing filled in. So now I'm going to work on the feed template and I guess starting with trying to get a video to play back on the home screen. This turns out to be as easy as adding a React Native video view and setting it to fill the height of the screen. And then we can set the source to the URL of an online video. Now if we add an overlay with caption text along with a like and comment section, dare I say, it looks like we're 90% done. Alright, it's 10:30. That took me over an hour basically, which is kind of unfortunate for the rest of this challenge. We'll see how it goes. We've got a long way to go, so let's get going. We can turn this into a scrolling feed by wrapping our video components in a flat list, and then we can use some built-in settings like paging and snap to interval to get the effect we're looking for. When the user scrolls to the next video, I'll just play the one that is currently visible and deactivate everything else. Haters will say this is impossible, but I have the power of ChatGPT and Copilot on my side. Alright, so that took another hour and a half, but now I've got a scrolling feed of videos here. So this is just stored in a list with the video data for now, but soon we'll be loading that from the back end. But anyway, you can swipe and then move on to the next video. And there we go. So yeah, this is looking very TikTok-like so far. Now what I'm gonna try to do is replace these public domain video URLs with our own videos, which we're gonna need to store on the cloud somewhere, and I'm gonna use Amazon S3 for that. At this point, I'm going to introduce the back end of our app. What is a back end, you ask? Everything we've been working on so far is considered the front end, the part of the app that users interact with on their devices. But behind the scenes, we need a back end to handle data storage and communication. To store data like user accounts, video captions, likes, and comments, we'll use a relational database. This type of database organizes information in tables and is optimized for efficient data lookup and concurrent modifications. We also need a way to store media files, like all the cat videos people upload. It wouldn't make sense to store bulky video clips directly inside our database tables, so instead we'll use a cloud storage service like Amazon S3. Think of it like Google Drive, but designed to handle massive content libraries for billion-dollar companies. Lastly, to connect our data storage with the front end, we need a back-end server. This server will receive requests from users' devices, talk with the database and storage system, and then send the necessary information back to the front end. The back end and its users communicate using a RESTful API, meaning they send HTTP requests to specific URLs known as endpoints. For example, the first table we'll add to our database will store user account information, with columns for username, email, password, and so on. When a user attempts to log in, the front end will send their credentials to the API endpoint TikTok API login, where the back end will check if a matching user exists. If valid, it will respond with a success message and return an authentication token, which the client must include in future requests to access protected features. It's now 2:30, so I've made some exciting progress. I've got the backend set up with django now, and I've ripped a template for the authentication system from a previous project that I have. So I have a login page here on the app, and if I go ahead and use my credentials from an account I made earlier, then I can log in, and then it takes me into the home page. Now, the other cool thing that I did is that you'll notice the videos are no longer the public domain videos that I had before. Now, all my videos are going to be stored in the cloud in a Amazon S3 bucket. So I just uploaded these files manually from the dashboard, but the next step is going to be uploading my videos from the device into the cloud. In order to accomplish this, we can create an endpoint on our backend called upload media. This endpoint will obtain a pre-signed upload link from S3, and then we can send that link back to the client. Then the client will upload the video directly to our S3 instance with the given URL. With this method, we can avoid storing our AWS credentials on the user's device, aka the front end. It's now 6:30. The last few hours have been a bit of a blur, and I don't really want to talk about it, but I spent way too long on the logout screen and with caching the access token. But anyway, I've just made a breakthrough. So if I go over to the emulator here, you can see I've got a create tab here with a button to open the image gallery of the native device. And then I took this video on the emulator and it's in my photo gallery. So then if I click that, then you can see there's a message that says we have successfully uploaded the file. And then if I go ahead and refresh our S3 bucket, then you can see that our video has been loaded here, and I can download it and then play it on this device. So now we were able to take a video from the device's photo library and then upload it to the cloud, and then we can use the cloud link in order to display it on everybody's devices. Now I'm going to want to store the video metadata and then a file path to access this video from the S3 instance, and then I'll be able to populate the feed with videos from the S3 instance. So I'll do that now, and then hopefully we can get some sort of ranking system for the videos done by the end of this. But before that, I'm feeling pretty confident about our timing actually, so I'm gonna hit up a quick gym session and get some dinner, and then I'll be back and feeling refreshed for the last half of this challenge. It is 10:45. I've got blood flow to my brain, I've showered, I've had dinner. I've spent way too long trying to compress the videos before I upload it. It's a massive headache with trying to get the Expo libraries installed. But anyway, we're more than halfway through the allotted time, and things aren't looking too good. It's time to lock in because we've got a lot more to do. It's gonna be a long night. I proceeded to spend 4 more hours trying to install the FFmpeg package. So it's 3:30. I've got like literally less than 6 hours left and nowhere near what I want to get implemented. So I'm just gonna do as much as I can in the remaining time that I have and see where I get and go at this with a vengeance. I think I might be running out in the snow later today. I'll probably be giving less updates because I really do not have time. I'm imposing a consequence if I don't meet this deadline. So now the user can upload their video files to our cloud storage, but we need a more structured way to store all the other information associated with each post. This would be stuff like the video caption, number of views, number of likes, date uploaded, and user that created the post. To manage this, we'll add a post records table in our database to store all the video metadata, along with the S3 file path that points to where the video itself is stored in our bucket. We'll have an endpoint on our django server that accepts a message with all these post details and adds the corresponding information to the database. And since we're going through all this effort to store video captions, we should probably provide a way for the user to caption their video before they post it. So that requires taking the user to another screen after the video finishes uploading, where they can enter in a caption and submit the post. With this critical step completed, we can create an endpoint that allows the front end to request a feed of videos. And for now, we can just send back the entire list of video information from our database. Remember that list of video data that was hard-coded into our app? Now we can finally populate this data dynamically from the backend via that API request. At this point, a user can upload a video from their camera roll, add a caption, post it, and then the video will actually show up on the home page for other users to see. Another cool thing we can add now is a profile page. To implement this, all we need to do is ask the API to give us all the videos that belong to a certain user, and then display those instances in a grid. I figured this was a high priority feature because this will allow you to delete your posts from the app and see all the crazy likes and comments that you've gotten. Speaking of likes, it's super easy to hook this button up to an API call which finds the record for the corresponding post ID and increments the number of likes by 1. Comments are a bit more tricky. There's a couple options for how we store these in the database. We could use an unstructured list of strings inside the post record, but if you think about it, we probably want each comment to be stored along with some related information, like which user wrote the comment, the date it was added, and the number of likes that the comment has. So we can actually just add another table for comments and use what's called a foreign key to associate each comment in the list with the corresponding video ID. ChatGPT helped me add this window that slides up from the bottom and displays a list of text. All I have to do now is populate that list with an API request that queries the comments table for all the comments that have the specified video ID. And of course, we need another endpoint to post a comment, which will add a new record into the comment database. Isn't it crazy how much faster you can get things done when you aren't trying to figure out unknown build errors? I was definitely panicking though. It is 7:30 now, and I have got a lot of things done, but I still need to actually try and rank the videos in the feed somehow, and I've got an hour and a half. So yeah, I'm gonna do that. So right now, the app is set up to display all the videos that people have posted, ordered by the number of likes that they have. This is a decision. But I think most people would agree that one of the core features of TikTok is the scarily addictive recommendation algorithm that learns your interests over time. I have a pretty cool idea about how I can implement this functionality in the simplest way possible. And even though an hour was nowhere near enough time to get this done, I just couldn't leave it out. My idea is to use vector embeddings for this. An embedding is a way of encoding features like images, videos, or text as a list of numbers. This can be done in a way that can capture the meanings and relationships between the original data. So if we could get the embeddings for each post and try to visualize them in 2D space, a post about hockey would be very close to another post about football, but very far from whatever this is. Here's where things get interesting. Imagine we also have an embedding that represents a user Charlie's interest, and it's somewhere around here, representing the fact that Charlie is interested in sports videos. If we want to rank the videos in Charlie's feed based on how likely he is to enjoy them, all we have to do is compare Charlie's interest embedding with the embedding that we've stored for each post in our database, and then sort them by similarity. Now there's still one missing part. How do we know what Charlie is interested in the first place? Well, imagine that we start with a random vector to represent Charlie's interests, but then Charlie likes one of the posts about football, and he watches it 90% through. Now we could apply a delta to Charlie's interest vector in the direction of the football post with a magnitude that scales depending on how much he engaged with it. Over time, we'll learn to recommend videos that are more similar to the videos he's previously engaged with. And the cool thing is, if Charlie later starts engaging with comedy videos, his interest vector will shift in the comedy direction, causing the algorithm to start recommending comedic sports videos. It's not actually too hard to implement this. First of all, when a new video is posted, we need to obtain its embedding and store it in the video record. For now, I'll use an API from OpenAI to generate a text embedding based on the video's caption. Secondly, we'll add a column to our user data table to store a list of embeddings corresponding to the user's interests. Now comes the hard part. When the user swipes past a video, we need to send an engagement score from the front end to the back end so that we can shift the user's interest vector in the direction of the video. Obviously, I had no idea if this would actually work at this point, so you'll have to wait for the end of the video for me to test it out.
Less than 10 minutes left. Will he do it? And he's still going. Why is he still going?
So it is nearly 11 a.m. I am tired. I am depressed. I feel like I could have been 100% there if I didn't have to spend so much time on that stupid Expo package issue, but you know what? That's part of the game. So what happened? Well, I decided to make a bunch of crazy changes in the last 30 minutes in an attempt to get some cool stuff in, and then I had to spend 2 hours debugging it and making sure that it would actually compile so I could show you what I have. So what do I have? I'm going to fast forward my demo here because it's boring and the app was really laggy on the emulator. I'll show you the actual finished product on my own device at the end of the video.
Basically, all the things I got done included user account creation, a home page with an infinite scrollable feed of videos, posting videos from your camera roll, comments, likes, and a profile page.
So I guess I'll leave it up to you if this counts as like making TikTok in 24 hours. But, you know, fair is fair. I did go an hour and a half over my deadline, and I don't even have the app running on a physical device. So unfortunately, I think I know what I have to do.
It happened to snow on the night of the challenge, and believe it or not, this was the heaviest snowfall that we've gotten in years. So this was my idea for an embarrassing TikTok.
Texas snow angels. There's nothing there. So obviously I didn't get anywhere near being able to release the app within the 24-hour period, but I still want to get it in a finished state and actually launch it, partly just for fun and partly as a way to show that it actually works. I didn't want to ruin the spirit of the challenge, so I try not to go too overboard here. The biggest changes I made were related to the recommendation algorithm. Remember the example I gave of a user's embeddings moving from the sports section towards the comedy direction and causing the algorithm to recommend comedic sports videos? Well, believe it or not, it's actually possible for humans to have multiple interests. So Charlie could like sports videos and comedy independently, and our current system has no way of representing that without trying to blend the two interests.
In order to account for this, we can store multiple embeddings for each user, where each embedding represents an interest that the user has. Now for each video that the user engages with, we will either adjust the embedding for the most similar interest group or add a new interest group if there are none that match. I'll also store a weight for each embedding to keep track of how strong each interest is, and then adjust that weight over time based on engagement scores from similar videos.
Since I was putting so much effort into the recommendation algorithm, I really wanted it to work. And I didn't think the current method of generating the video embeddings with only the caption would cut it. I wanted to include audio and visual information from the video to really capture a good representation of each post. At first, I tried running AI models locally to generate image captions for a few frames and transcribe the audio. But later I realized that I couldn't run these on the resource-constrained AWS servers.
Instead, I resorted to some paid APIs. OpenAI's Whisper to transcribe the audio, and GPT-4 to take the transcription plus a few frames from the video to produce a summary. It seemed like this would turn out cheaper than paying for the AI-capable AWS servers. Then we can use all that combined to create the text embedding. There's definitely ways to generate actual video embeddings, but I thought it would be easier to test if I kept everything in a text format. And since this process takes some time, I have to add a task queue with Celery that can run the embedding generation task in the background after the video has already been posted. We can compute an interest score for each video relative to a user by taking the similarity times the weight for any of the user's matching interest groups. I can then combine that score with other factors, like recency and number of likes, to get an overall ranking. So how do we use this ranking system to actually construct a feed for the user to view? The original way I had it set up was to sort the entire list of videos by their ranking score and then show them to the user in exactly that order. But then the user might never see new videos outside of their interest bubbles. A more realistic approach is to conduct a random weighted sample using all the videos, so higher ranking videos are more likely to appear, but there's still some variety. This introduces some added complexity, because now we have to store all the videos that the user has seen before and filter them out of this weighted sampling. And because it would be horribly inefficient to compute the personalized rankings for every single video every time, I cache each user's rankings for a 30-minute interval.
There are endless ways to set this up, and I really have no idea how apps like Instagram or TikTok actually implement their recommendation algorithms, but I'm having fun trying to design a system that would actually be functional and scalable for a decent amount of users.
Finally, in order to actually deploy this, I spun up an AWS EC2 instance to host our server and migrated the database to RDS.
I also noticed the videos were buffering a lot, so I converted them all to the HLS streaming format. I also set up Amazon CloudFront to reduce latency. And even though I know it's been like 2 months since the 24 hours have passed, I promise you this didn't take more than a couple more afternoons. Okay, it was actually a lot of afternoons. Here's the final list of all the endpoints that I implemented for the app, and here's the full diagram of the completed database design. I wanted to be able to test if my recommendation algorithm was actually working, so I basically brain rotted for a few hours, downloaded a bunch of Reels and TikToks, and then reposted them on my platform. Here's a visualization of the embeddings that were automatically generated for each post. I also threw in a bunch of random video categories to show how they're arranged in the embedding space. Keep in mind that these vectors exist in over 100 dimensions, so we're losing a lot of information when I project them into a 2D coordinate system. But you can definitely still tell that similar categories tend to cluster together. For instance, all the dog videos group near the pets label, and a post about weddings clusters near a post about relationships. Now watch as my embeddings shift around in this space as I scroll through the videos on my account. I intentionally engaged with a lot of pet and motorcycle content, and you can see that these categories ended up with the highest weights. I also added a page on the app that reports how well your interests correlate with a set of text categories. And sure enough, the motorcycle and pets categories ended up with the highest score. Oh, that doesn't look right. There we go. Unfortunately, I was definitely noticing some limitations with this text embedding approach. If I set the interest match threshold too high, too many interest embeddings get created instead of clustering together. But if the threshold is too low, everything collapses into one big interest group, especially when the vector starts to get muddled and pulled in different directions. I could dedicate a whole video to experimenting with different recommendation algorithms, but I think this is good enough for now. Now that everything's finally done, I rebranded the app to PopOff in order to attract my target audience of middle schoolers, took some screenshots, and submitted the app to the App Store. You can now download it on iOS and Android, at least for the next couple of weeks.
Actually, the Google Play Store has this dumb policy, so if you have an Android and want to try the app, there's a link in the description to register as a tester. I'd encourage you to go try the app for yourself and have fun with it. But here's what it looks like running on my device. I had to add features like reporting and blocking users in order to get past Apple's review process, so I went ahead and spent an afternoon adding some extra functionality, like a way to download videos, a following page, and a way to search for users. And here's what it looks like to post a video. I was really happy with the responsiveness and overall feel of the app, which were much improved running on actual hardware.
So I've released a TikTok clone on the App Store. The only problem is it's kind of useless for a variety of reasons. It's very unfinished and missing a lot of essential features. TikTok probably will never be banned anyway. There's already a few TikTok ripoffs on the App Store that are doing quite well. I don't have the buttload of music licensing agreements that TikTok has, and I don't really want to put in any more time to continue updating and maintaining the app, even if anyone was to download it. So the options I have are 1. Keep the app up for a week or two as a little tech demo before I take it down forever. 2. Try to come up with some sort of unique selling point that differentiates the app, make the branding less cringe, spend a lot of money on promotions, look for investors, and make bank, probably. 3. Convert the whole thing to an open source project. If you have any cool ideas for the future of the app, please feel free to leave them in the comments. And now we come to the actual conclusion of the video, and to wrap things up, I'd like to give some credit to my boy Chat. But really, I feel like I physically coded less than 10% of this app. Even without the 24-hour time crunch, why would I ever type things out manually again, when Copilot can basically read my mind and autocomplete entire functions at a time? Basically, my vibe coding skills are off the charts. I had never built a full-stack app before this challenge. I had barely touched React Native, AWS, or Django. But after this little exercise, I'm confident that with the help of AI tools, I could build any sort of derivative mobile app in under a week. Think about it. Twitter, Instagram, Tinder, all these billion-dollar companies are essentially the same. A fairly simple front end, plus cloud servers that hook into a big database and serve users an infinite scrolling feed of content. That's it. And all this is a bit scary for CS students like myself. But on the flip side, if you're even a halfway decent developer with a cool idea, there's no reason you can't build it now, solo, within an incredibly short time frame. And that's actually quite empowering. So what I'm saying is, you have no excuse for not making cool things. And that goes for me as well.